This video is a continuation of 5.10, which is the optimization problems. And in this video, we're going to look at example 3. This is a pretty common example for optimization problems. So it says a rectangular page is to contain 24 square inches of print. That's going to end up to be our given information. The margins at the top and the bottom of the page are 1.5 inches, so they have it all here in the picture. And the margins in the left and the right are 1 inch. What should be the dimensions of the page? So what should be the dimensions of the page? We have to make sure we answer the question when we get to the end, so that the least amount of paper is used. So we are trying to minimize the area of the paper. So they want to use the least amount of paper. Okay, so what we are given is this 24 square inches of print. So that's this. So you can think the area of a rectangle is length times width. But because they're already using X and Y, the dimensions of the print are Y and X. So area is just X times Y, and they told us it is 24. So 24 equals X times Y. That's our given. And then what are we finding? We're finding the area of the whole page. Oops, I need to move over here. So again, area of a rectangle is normally length times width, but we're going to use X times Y. But notice Y is the width of this print. So my area of the page would be Y, and then adding in this inch and this inch. So this width would be Y plus 2. So my area would be width times length. Well, that would be Y plus 2. I feel like I need to zoom in here a little bit for you. And then the height or the length, whatever you want to call this, which is X. And I have to add in this 1.5 inches and 1.5 inches. So this full dimension from the top to the bottom here would actually be, oops, not W, X plus 3. Okay, so this is X plus 3. So this is what I'm trying to find, the minimum of this function. And remember, we want to have this function be with respect to a single variable. And I'm going to use this function to get a single variable. So I'm going to solve for Y, you could solve for X, and you would end up with the same answer. So I'm going to replace every Y with a 24 over X. So I'm going to say my area, well, I'm going to go down here. Instead of Y, it's going to be 24 over X plus 2 times X plus 3. And then I could do product rule, but I'm thinking I just want to multiply it out and turn it into a regular polynomial. So if I multiply first times first, I'm just going to get 24. If I multiply the outside, I'm going to have 24 times 3, which is 72 over X. I'm going to write that as 72x to the negative 1, because I know I'm taking the derivative. Inside times inside is 2x, and last times last is 6. Okay, now let's find the derivative of this function. So a prime is going to be 0, and then the derivative of this would be negative 72x to the negative 2 plus 2. Okay, so that is my derivative. I need to set that equal to 0 and solve. So I'm going to get rid of that negative exponent. So I'm going to have negative 72 over x squared plus 2. And then I'm going to combine those, get a common denominator, which would be x squared. So then I would have negative 72 plus 2x squared over x squared. And just because I don't like a negative out in front, I'm going to write it as 2x squared minus 72 over x squared. Okay, so a prime will equal 0 when the denominator equals 0. So when 2x squared minus 72 equals 0, and blah, 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 you're going to get x squared equals 36. That blah, 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 blah is some simplifying, which you can pause and do, or x equals 6. Okay, we're ignoring the negative one because this time these are dimensions, so we're going to ignore the negative. The other thing you need to note is critical points are when the derivative is 0, which we just did, or when the derivative is undefined. Now this would be undefined when x equals 0. But if you think about it, x is not going to equal 0 because that would not make sense in this situation to have x equals 0. So we're disregarding that, okay? So a prime is undefined when x equals 0, which would give us x equals 0 and will be disregarded because we're not going to have an area where we have all y and no x. All right, so we need to reestablish or establish if that is a min or a max, because remember we're trying to minimize. So I'm going to use second derivative test, which I'm going to abbreviate as SDT. So find the second derivative. Where is my first derivative? Right here. I'm going to go back. I'm going to go back to this one and do second derivative, because then I'm going to get positive 144 x to the negative 3, which is 144 over x to the third, and then I want to evaluate the second derivative at 6, which is going to get me, I don't really care what the number is, all I need to know is that it's going to get me a positive number, so I am concave up, so x equals 6 is a minimum. If I'm concave up at 6, then I do have a minimum. Okay, so now we want to make sure we answer the question that was asked. So I know x equals 6, but the question asks, what should the dimensions of the page be? So remember, x is just the print. Let me go back over here. X is just the print. I want the dimensions of the page. So for the dimensions of the page, it would be 6 plus 3. That would be 9 inches. And then if x is 6, remember, x times y equals 24. So if x is 6, that means y is 4. And then to y, I want to add 2. So 9 inches, and then the other dimension. So this was x dimension, y dimension. Y is 4, but it would be 4 plus 2, so that would be 6 inches. So the page should be 6 inches by 9 inches. Okay, that is the minimum size that the page can be. All right, I'm going to put example 4 in another video.